Special limits. So we have a few special limits here. The limit as x approaches 0 of sine of x over x is equal to 1. So this is, we're going to learn more about how this works later on. I'm forgetting if it's in your Desmos activity. Basically, you can graph it and figure that it's 1, but we'll learn a special rule in chapter 5 that'll also help us figure out what the limit as x approaches 0 of sine x over x is. Because like really, if you plug in 0, sine of 0 over 0 is 0 over 0. But if you graph it, it looks like this. There's like a hole there at y equals 1. Anyway, so that's sine of x over x, so that equals 1. So this is just a special rule. And then we have another special rule that the limit as x approaches 0 of cosine x minus 1 over x is equal to 0. So these are just things that pop up once in a while, just these special trig ones. So the limit as x approaches 0 of sine of 4x over 3x. So we have the sine of x over x, but not the sine of 4x over 3x, right? So one way that you can deal with this is like use u substitution. If I let u equal 4x, then x is equal to u divided by 4, right? So what I can do is use u substitution. So the reason that I chose u is equal to 4x, again, is because I know my rule is sine of x, sine of like a plain old x, so I'm going to do sine of plain old u. Now, if x is approaching 0, and we have this expression here, plug in x equals 0, what do you get? U equals 0. So the limit as u approaches 0 also works, because if x is equal to 0, u is also equal to 0. And then that would be sine of u over 3, and instead of x, x is equal to u over 4. And then I'm just going to do a little bit of algebra here. That's the limit as u approaches 0 of sine of u over 3/4 u. That's the limit as u approaches 0 of sine of u over u. And then instead of dividing by 3/4, that's the same thing as multiplying by 4/3, right? Instead of dividing by a fraction, you can multiply by its reciprocal. Okay, so what does the limit as u approaches 0 of sine u over u equal? That equals 1. So your answer is 4/3. So this is how you can deal with special limits, is you can use u substitution. So again, I chose u is what we're taking the sine of. U is equal to 4x. I solved for x because I needed to be able to replace both of these expressions in terms of u. The limit as x approaches 0 is the same as the limit as u approaches 0, since we have this equation. If you plug in x equals 0, then u also equals 0. Replace all your x's with functions with expressions in terms of u, and then once you get sine of u over u, you can use our special limit and replace it with 1. All right, and lastly, algebraic limits. So jump right in. First thing you always want to do is see what happens if you plug in the number. So if I plug in I don't actually have to write limit 2 here, because as soon as you plug in the number, you don't have to write limit anymore. You only have to write limit as you're simplifying expressions. So as soon as you're plugging in the number, you can stop writing limit. So that's 13 over 4. Okay, that's my answer. Done. So that's always the first thing you should try, is just plug in the number. So like here, if I plug in 2, I would get 2 squared plus 2 minus 6 over 2 minus 2, which is 4 plus 2 is 6 minus 6 is 0 over 0. Okay, so that is indeterminate form, which means I need to do more. Isn't that super cute? Mrs. Kelly taught me that trick. 0 over 0 means do more. So that means try factoring or simplifying trig functions or using conjugates or whatever. So 0 over 0 means you have to do something else, but it's still solvable. So what I'm going to do is simplify my limit. This one I can see is factorable. And because I'm simplifying my expression, notice that I'm rewriting limit. I'm not just simplifying the expression without a limit. So that's x minus 2 times x plus 3 over x minus 2. So that's equal to the limit as x approaches 2 of x plus 3. And then because now I can plug in 2, I can stop writing limit. So again, as soon as you plug in the number, you don't have to write limit. So that's 5. All right. So if I plug in 0 for this third expression, I get 2 minus root 4 over 0 minus 0. So that's 0 over 0. Okay, what does 0 over 0 mean? It means do more. Okay, so, okay, you know what? I'm going to stop writing do more, because if you wrote that on an AP test, I bet your grader would be super... super confused by that. Okay, so 0 over 0 means I need to do more. So I'm going to go ahead and I see that I have a radical. I have a square root. So I'm going to multiply by the conjugate. So the way that a conjugate works is take your expression and then multiply by the exact same expression, but whatever sign is in between, just change it. So the conjugate of 2 minus root 4 plus x is 2 plus root 4 plus x. Notice I'm not changing the plus part. Whatever's in the square root needs to stay the same. I'm just changing the sign on the square root itself. And the reason that you're doing that is you're creating a difference of squares, like a squared minus b squared, right? A squared minus b squared is a minus b times a plus b. That's what you're doing here. You've got a minus b, a plus b. So that's a difference of squares. That's what we're doing. Now you're not allowed to just multiply your numerator by that value. You need to also multiply your denominator. You can't just multiply one side. You have to do both. All right, and again, I write the limit as x approaches 0. Until I plug in 0, I have to write limit. And then you can, this is a difference of squares, so it's going to be 2 times 2, which is 4. Minus, and then root 4 plus x times root 4 plus x is 4 plus x. Make sure you use parentheses, because that negative needs to apply to the whole radical. Over, okay, now here's the trick with conjugates. When you create a difference of squares, yes, simplify your difference of squares. But the side that isn't a difference of squares, you want to keep factored. You're just going to have to trust me on this. You want to keep the other side factored. In fact, I haven't even factored this side. I can factor that a little bit. That's 4x times x minus 2 times 2 plus root 4 plus x. So don't FOIL out the other side. Only multiply out the side that creates a difference of squares. Okay, and then we keep simplifying. I know it'll be ugly for a second. 4 minus 4 is 0. 4 minus 4 is 0, but then you still have that negative x there, so don't forget to apply that negative x over 4x times x minus 2 times 2 plus root 4 plus x. So I simplify my numerator. Hey, x divided by x cancels. So now I can plug in 0, because now if I plug in 0, my numerator is just -1. My denominator is 4 times 0 minus 2, which is -2, times 2 plus root 4. So that's -1 over -8 times 2 plus root 4 is 2 plus 2, which is 4. So that is 1 over 32. Okay. So again, I mean, like really all, this is not even calculus, this is all algebra, right? Like multiplying by conjugates, recognizing you need to because you have a radical expression, creating a difference of squares, foiling, multiplying out, make sure you distribute negatives, factoring, but just a lot of algebra, okay? All right, and then last one, the limit as x approaches 2 on the positive side. So usually what I do is this, when I'm solving a limit on one side, is I'll plug in a number really close to 2, but on the positive side. So what I'll do is I'll plug in like 2.001. And I'm going to put about equals because it's not going to be exact. So that would be 5 times 2.001 plus 3. over 2.001 minus 2. Actually, this part is equal. My next part is where it's going to be about equal to. 5 times 2.001 is about 10. 10 plus 3 is about 13. My denominator, 2.001 minus 2, is 0.001 squared, which is 13 divided by 1 out of, so that's the thousandths place, squared. Now, instead of dividing by 1 over 1,000 squared, that's the same thing as multiplying by 1,000 squared over 1. Okay, now, is the actual answer 13 million? No. The point of this is if we add more and more zeros, because right now we're pretty close to 2, but we're not like super close, like really close would be 2.00000000001. The point of this is just to make a point. The more zeros I have, the larger this number will be, which means overall, this is going to be a really, really big number. This is approaching positive infinity. So the point is, the closer I am to 2, the closer a number to 2 I plug in, so 2.00001, the closer my denominator will get to 0, which will make the overall numerical value of this fraction closer to infinity. To finish off this video, I just wanted to go over this one problem that is new to this year. I didn't have it in my video from last year. So if you plug 2 into this function, I would get the square root of 0, which of course is 0. However, the actual answer does not exist. So I just wanted to talk about what happens when you have an endpoint. So the square root of 4 minus x squared, as you know, looks like this. 1, 2, 1, 2, 1, 2. It's a semicircle. And as x approaches 2, you are approaching 0 from the left. So if this was like just a left-hand limit, then I would say that the answer is 0. But since we don't have a left-hand limit, that means it has to approach 0 from both sides, or it has to approach the same y value from both sides. From the left side, we are approaching 0, but from the right side, we're not approaching anything. There is no right-hand limit. So we would say the limit does not exist because the limit as x approaches 2 on the left side, the limit as x approaches 2 on the right side of f of x doesn't exist. If one side doesn't exist, then the entire limit cannot exist. Or if the left and right hand limits do not agree, then the limit does not exist. So if your function is not approaching the same y value on both sides, then the limit does not exist.